Hi everyone, we're going to do the Jee Main Exam from August 31st, 2021. It was the 9 a.m. till the 12 p.m. test. Here's question number 10 for you. Let's read it together. It says, a 0.1 molar solution of which electrolytes show most depression in the freezing point. And then they give us 4 electrolytes. We have glucose, we have our potassium hydrogen sulfate, ethylene glycol, and glycerol. The answer is right here. If you understand this, it's because there are 2 particles. Now, if this is new to you, you don't quite understand, watch the rest of the video. So here's our formula for colligative properties, freezing point depression. The change in temperature for freezing point, and little reminder, the freezing point will always go down as you increase the number of particles. Freezing point is always depressed when you add a solute to a perfect or a pure solvent. So that change in temperature is going to be I times Kf times m. Now I is what we call the Van Hoft factor, and that's how many particles a substance will break into, and that's unique to colligative properties. It honestly doesn't matter what the substance is, all we care about is how many particles it will produce in that solution, the solute particles in the solvent solution. Now the Kf is just the freezing point depression constant. That's going to be for the solvent. So if you're dissolving in water, for example, it's going to have a certain constant. Little m, that lowercase m, is called molality, and that is moles of solute divided by kilogram of solvent. So as we look at this, really important fact that you need to know. A non-electrolyte, so something that is not going to dissolve in water, it stays as a whole molecule, it's always a Van Hoft factor of 1 because it doesn't break apart. So check this out. The glucose, ethylene glycol, and glycerol, those are all molecules. They are not going to dissociate. They're not going to ionize when you put them in water. They're a non-electrolyte. They don't produce that charge, a minus or a positive charge. So their I is 1 particle. And now look at the potassium hydrogen sulfate. It dissociates into 2 particles. So you're just dissociating into the cation and the anion. We're going to have the potassium cation and the hydrogen sulfate anion, and that's 2 particles, 1, 2. So the I is 2. Now if you look at our formula, change in temperature for our 3 non-electrolytes, you'd have 1 particle times Kf times m. And remember, that's going to be the same as this over here because we're told they are all a 0.1 molar solution. The change in temperature for our potassium hydrogen sulfate is 2 times that Kf, the constant, times the molality, which is still 0.1. So this is going to have 2 times the depression, a lower freezing point depression. Okay, good job. I will link up above a couple of helps for you if you feel like you need some more direction on this. Good work. Thank you and have a good day.